Now let's do a simple exercise, an exercise in which the line is parallel to VP and inclined to HP. The line is parallel to VP and inclined to HP. So write down this question. A line DE 60 millimeter long is parallel to VP and inclined at 45 degree to HP. Draw the projections of the line if DE is 10 millimeter above HP and 25 millimeter in front of VP. Mark its trace. Now, in order to solve this one, first we have to draw the XY line. First I will show you how to draw it and then you complete your drawing. So first you have to draw the XY line. Then first we have to mark the point D, the projections of the point D. It is 10 millimeter above the HP, so D dash will be 10 millimeter above the XY line, and the point D is 25 millimeter in front of VP, that is in the first quadrant itself. So the top view D will be 25 millimeter in front of XY line. So that we have marked. Now what we have to do is, in the front view, draw a horizontal line. Draw a horizontal line through D. Why we horizontal line through D dash? In the front view, we draw a horizontal line through D dash. Why we need this line? This is to mark the angle. This is to measure the angle. So in order to measure the angle 45 degree with the XY line, and a line passing through D dash is to be drawn. So this line is necessary. If we doesn't draw this line, the exact 45 degree may not be there. So draw a horizontal line through D dash. This horizontal line should be parallel to the XY line. And from that point, from that line, mark a distance, mark an angle 45 degree, keeping the index point of the protractor at this position. The index point of the protractor should be kept at this position, and mark an angle of 45 degree in the anti-clockwise direction. So you will get, then join the line, join the 45 degree mark a point with the D dash and extend that line to 60 millimeter. Extend that line to 60 millimeter. 60 millimeter means 6 centimeter. So that this point will be E dash. Now this point is E dash. Now what we have to do is, we have to mark the angle, that is 45 degree. Now we drop projector from E dash also. We drop a projector from E dash. This E projector should be such that it is making an angle of 90 degree with XY line. This E dash, that line through E dash, this line, it should be making an angle of 90 degree with the XY line. And now finally what we have to draw is, we have to draw a horizontal line through D, so that this line through D should be parallel to the XY line. So a horizontal line parallel to XY line is drawn through D to intersect with the projector through E dash. To intersect with the projector through E dash. So this line is the top view. So this point, this end point can be marked as E. Now what you have to do is, you have to complete the trace also. You have, in order to mark the trace, what you have to do is, you have to extend the line D dash E dash so that it intersects with the XY line at the H dash. Then from H dash drop a projector so that when D and E, the line DE is extended, it intersects with this projector at a point HT. So this is the complete drawing. So now one more time I will explain it step by step, and during that time you can draw it. To draw the horizontal line to mark the XY line. So draw the horizontal line, XY line. This line should be thick. This line should be thick. Now from any arbitrary point, any point you can take, but it should be towards the x side, because we have to mark D towards the right. So x, we have to mark the second point, that is E. E should be towards the right, so it should be towards the left side, left of the y, or towards the left of the line. So this line is, on this line mark 10 millimeter, and D dash is marked, and extend that line downward also, and on this point at 25 millimeters below the xy line, mark point D, and from D dash draw a horizontal line which is parallel to the xy line, and now from this line make an angle of 45 degree using your protractor. Mark an angle of 45 degree with your protractor, and then join the marked point, that is the 45 degree measured point, with the D dash, so that the length of that particular line is 6 centimeter. In this case 60 millimeter. 60 millimeter is equal to 6 centimeter, so mark 60 millimeter there, and the E dash is obtained. Now the angle can be written. Mark the angle, that is 45 degree. Now from E dash drop a projector. Now from D draw a horizontal line which is parallel to the xy line, and the point of intersection of this line with the projector through E dash is point E. So now the projections are complete, that is the front view as well as the top view is completed. Now extend the front view towards the xy line. Extend the front view towards the xy line, and the point of intersection of this extended line as well as xy line is known as H dash. Mark it as H dash. Now drop a projector from H dash. Drop a projector from H dash, so that when D and E, the top view is extended, it should meet the projector through H dash. Now extend the top view so that it intersects with the projector through H dash, and this point is known as the HT. Now you have to give the dimensions. For D dash it is 10, and to D it is 25, and for the true length, the actual length, it is 60, and 45 degree we have already marked. So all the given dimensions, all the dimensions given in the question should be marked in the answer also, and one dimension is to be marked only once. Even if it is occurring multiple times, you have to mark it only once. So in this case, the dimension that is to be marked is 60 millimeter, that is the true length, and the inclination 45 degree, and the position of D with respect to HP, and the position of D with respect to VP. Only 4 values are to be marked, and this is the final drawing. And in the final drawing, you should remember that D dash, E dash is to be dark, as well as DE should be dark, and the XY line should be marked, should be dark. No other line should be dark in this drawing. All the other lines should be thin lines as well as very light lines. So now we move on to another problem, another example, in which the line is parallel to HP and inclined at 45 degree to VP. So these concepts are very important, because from now onwards we will be going for lines inclined to both HP and VP. Unless you understand these concepts till now it is very easy also. Unless you understand these concepts, it will be very difficult for you to understand what we will be doing in the cases of lines inclined to both HP and VP. So the next exercise, a line EF 60 millimeter long is parallel to HP and inclined at 45 degree to VP. Draw the projections of the line if E is 15 millimeter above HP and 10 millimeter in front of VP. Mark its trace. So here what is happening is the line is parallel to HP and inclined at 45 degree to VP. When the line is parallel to HP, we know that the front view will be parallel to the XY line, and since it is inclined to VP, the top view will be giving you the true inclination as well as true length. So let's see the condition. We first draw the XY line. The XY line is a horizontal line which is drawn horizontally, and it should be a thick line also. And then we draw a projector. This projector is to mark the front view of E as well as the top view of E. So front view of E is drawn. So E dash is 15 millimeter above the XY line. Since the point E is 15 millimeter above HP, the front view E dash is 15 millimeter above the XY line, and the top view it is 10 millimeter in front of VP, so the top view is 10 millimeter below the XY line. So these two conditions we can draw. Now, since we know that the front view is parallel to XY line, what we first do is we draw the top view first. So in order to draw the top view, first you have to draw this line, this horizontal line through E. This horizontal line through E is drawn in order to measure the angle 45 degree from this line. So this is 45 degree line, this is 45 degree, as we said in the previous case itself, but the only thing is it is the reverse. That is, in this case you have to start from the top view. You have to start from the top view, and then F is marked, and then F projector from F is drawn, and then a horizontal line through E dash is drawn. So then E dash, F dash is marked, and E dash and F dash is drawn as thick lines. Now, in order to get the top, the trace, in this case, the trace that we have is only vertical trace. So in order to get the vertical trace, what we do is we extend the line EF, the top view of the line EF, so that it intersects with the XY line. So that particular point is small letter V. And this V is projected to the front view or the extended front view. So E dash F dash is extended, and the point of intersection of this extension with the projector through V. This point is known as VT. This is the complete drawing. Now you have to mark the dimensions also. So this is this distance is 15 millimeter, and here it is 10 millimeter. And the true length is 60 millimeter. So you complete it. I will give you some 3 or 4 minutes, and you complete it, and then we will continue with our the next case, that is a line inclined to both HP and VP. Now we move on to the condition where the line is inclined to both HP as well as VP. Now let's see the pictorial representation. Actually, before going to the pictorial representation, I'll show you it in the Creo software, so that it will be easy for you to understand. Okay, here is the line. As I hope it is visible to you. So this is the line. Then this line is inclined to both HP as well as VP. See, it is neither parallel to HP nor parallel to VP. So it is neither parallel to HP nor parallel to VP. So it is inclined to both HP as well as VP. So in this condition, what is the dimensions? I mean, what is the inclinations? Let's see the actual inclinations here. So here you can see the actual inclinations in the placement. So here, this one, the angle offset, here it is 30 degree. That is the inclination with the HP is 30 degree. See, the inclination with HP is 30 degree, and the inclination of the line with the VP, the actual inclination of the line with the VP is 45 degree. The true inclination of the line with the VP is 45 degree. Now, so that's it. The true length of the line that we can see, the true length of the line is actually 10 centimeter itself, as we have already drawn. So the true length of the line is 10 millimeter, I mean 10 centimeter. Now, if I see that front view, see the front view is inclined at an angle, some angle, inclined at some angle with the VP, I mean XY, with some angle with the XY. In the previous case, when the line was parallel to VP, it showed the true inclination. It showed the front view showed the true inclination. But here, does it show the true inclination? Let's see whether it shows the true inclination. See, it shows an angle of 45 degree. Actually, what was the angle with which it was making with the HP? It was making an angle of only 30 degree with HP. The angle which the line was making with the HP was only 30 degree. But in front view, it is showing a 45 degree. Why is it? Is it a mistake? Mistake by chance? That is, it was actually making a 45 degree with the VP, and that's why the same angle came here. No, it's not like that. It is something different. Something different. In the case of the front view, what is the length that we have to measure? In the front view, what is the length? The length is only 7.07. The length is 7.07. In the previous case, we have seen that when the line was making an angle of 45 degree with the plane, the 45 degree was the angle with the plane, that in that case, that particular length in the projection was 7.07. So in the second case of what we have seen in the last case, in the last slides, what we have seen is when it was parallel to one plane and inclined at another angle to the other plane, we obtain a length 7.07 when it was making an angle of 45 degree with that particular plane. So in this case also, it should be making an angle of 45 degree with the VP. But in the front view, it is showing an angle of 45 degree. Why is it so? Because this angle is known as the apparent angle. The apparent angle is like this one. That is, it is somewhat larger angle than the actual angle. It is an angle that is an angle which is larger than the actual angle, the true angle. This is the apparent angle. This is the apparent angle in the front view. And we have seen that the line makes an angle of 45 degree with the VP. That we have already proved, because the front view, the length of the front view is 7.07. So obviously the angle which the line makes with the VP should be 45 degree. It should be 45 degree. But let's see in the top view, what should be the angle that we will see. So this is the top view, and we need the angle. See, here is the angle. It is an angle that is 54.7. Actually, it should have been 45, but it is 54.7. That is, this is the apparent angle with respect to the top view. So in the top view, the actual inclination with the VP will be given only when the line is parallel to HP. If we want the true inclination, the actual inclination with the VP in the top view, then the line should be parallel to the HP. It is the same case with the front view also. If we need the true inclination in HP, if we need the true inclination in HP, then obviously the line should be parallel to VP. If the line is not parallel to VP, then the inclination that the front view makes is not the true inclination. It will be an apparent inclination. As we seen in this case, it was 45 degree when we saw it. Actually, in our actual condition, it was the actual inclination was only 30 degree. And how to determine these angles? That can be determined only by drawing this one. Only by drawing. There are mathematical functions which uses this one, but in our engineering graphics, it is not important. We have to draw. We have to draw in order to find out the apparent inclinations. So this is the case, that is the line, and in this case, that in the top view, what is the length? That also let's see. The top view, the length is 8.66. We have seen this particular length earlier also, 8.66. That is when the line is making an angle of 30 degree. When the line is making an angle of 30 degree with HP, then the length of the top view will be 8.66. Here also the line is making an angle of 30 degree with HP, that we know. But in the front view, it is not showing 30 degree, but instead it is showing 45 degree. And the length of the line is 8.66. So if a line is inclined to one of the planes, and if that particular inclination is doesn't changes, say the line is inclined at 30 degree to HP. So the length of its top view will remain same as long as its inclination with HP remains the same. That is, as long as the length of the inclination of that particular line with HP remains 30 degree, the length of the top view will always be 8.66 if the length of that particular line is 10 centimeters. So this is the condition. So it is the length of the top view is dependent only on its inclination with the HP. It doesn't matter what is its inclination with the VP. The only difference that it makes is not in the length, but it's the orientation of that one. That is whether the top view is making an angle with XY line or not. Whether the top view, not the actual line, whether the top view is making an angle with the XY line or not. So in order to make an angle of some value with the XY line in top view, it should be having an inclination with the VP. If it doesn't have an inclination with the VP, it will be parallel to the XY line. But in this case, it is inclined at an angle to XY line, HP as well as VP, and hence it is showing some inclination in the top view as well as in the front view. So this is the case. That is, the inclination in the front view as well as the top view with the XY line is greater than or more than the actual inclination, when the line is inclined to both HP and VP. So that is the condition. Now we can move on to our presentation. So here VP as well as HP is given. Now XY line is here, and we consider a line AB which is inclined at an angle to both HP as well as VP. And in the front view, we drop a projector, and in the top view also we drop a projector. So this is the front view. And as I said, the front view is not making the true inclination with the VP. So this particular inclination is known as the apparent inclination, and alpha represents the apparent inclination in the front view. Alpha represents the apparent inclination in front view. And always alpha is either greater than or equal to theta. So that is true inclination with the HP. Alpha is always greater than, or at least it should be equal to theta. When it is equal to theta, then obviously the line AB should be parallel to VP. When line AB is parallel to VP, then alpha is equal to theta when AB is parallel to VP. So this is the condition. So alpha is always greater than or equal to theta, and alpha is equal to theta only when AB is parallel to VP. That is the condition in the front view. Now this is A dash B dash, and we drop the top view, top view is making an angle of beta, and the apparent inclination in beta, apparent inclination in top view is known as beta. So beta is always greater than or equal to phi, and beta will be equal to phi only when AB is parallel to HP. So these four conditions is again important. That is, alpha is always greater than or equal to theta, and alpha is equal to theta when AB is parallel to VP, and beta is greater than or equal to phi when beta is equal to theta. Beta equal to phi when AB is parallel to HP. So this is AB. Now, as usual, we drop the lines to project A dash and A, as well as B dash and B. Now, this is the representation. Now, on removal of the object, line AB. Now, if we consider this one, this figure, see, this is the front view as well as top view, A dash as well as B dash, A as well as B. So this is the front view as well as this is the top view. In this case, we doesn't know the true length of A dash as well as B dash. We know the true length of the original object, that is AB. We doesn't know what is the value of alpha, what is the length of A dash, B dash, what is the length of AB, what is the length of beta, unless we draw this one. And how to draw this one, that is the important part. How to draw this one. And this is drawn in such a way that we know that this length A dash, B dash is fixed. This length is fixed depending on the inclination of the line with respect to VP. Depending on the inclination of the line with respect to VP. So, in order to get this particular length, first what we do is we assume that the length is parallel to HP. The line is parallel to HP. A dash, B dash is, in order to get the length of A dash, B dash, what we do is we assume that the line is parallel to HP. When the line is made parallel to HP, we know that the top view will give you the true length. We already know that the top view will give you the true length when the line is parallel to HP. So that we have already seen in the previous two exercises. One of them was like that. The line was parallel to HP and inclined at an angle to VP. In that case, when the line is parallel to HP, the true length will be given in the top view. So first we draw the top view, and in that case the front view will give you the true length. I mean true length of the front view. The front view of that particular drawing will give you the true length of the front view, or the actual length of the front view. So in that way we can obtain the front view, the length of the front view. Then in order to get the length of the top view, what we do is, when the line is parallel to VP, we know that the length of the front view is the true length. It is a similar case in the previous two drawings. The line is parallel to VP and inclined at an angle to HP. In that case, when the line is parallel to VP, the length of the top view can be obtained. So likewise, by drawing two other separate figures, there is one which is parallel to HP and one which is parallel to VP, we can obtain the top view as well as the front view. But we doesn't go for separated drawings, but we incorporate all these drawings in the same drawing itself, in the same XY line itself. So then we obtain the front view as well as the top view. Then keeping one point fixed, keeping this particular point fixed, I am keeping this particular point fixed, and keeping the inclination with this line fixed, keeping the inclination with the HP fixed. If I rotate this line, or we make the line parallel to VP, something like this, if I make this line parallel to VP, in that case what happens is, if I this line, this B dash will be moving in a direction parallel to the XY line. The B dash will be moving in a line parallel to XY line. Why? Because since this angle is fixed, this angle is fixed, this distance is also fixed. This distance is fixed as well as this angle is fixed. This distance will also be fixed. This distance will be fixed, but the position of this will be rotating in a circular way. So if I rotate it, if I rotate this AB, if I rotate AB like this, I can rotate AB like this, so that it becomes parallel to XY line. I mean parallel to VP. So if I rotate it, the top view will be rotating like this, so that it will become parallel to the XY line, and the front view will be moving. The B dash will be moving like this only, in this direction only. Why? Because this distance, this vertical distance remains the same. So if I rotate it here also, this distance as well as this distance should be equal. These two distances should be equal. Since these two distances are equal, this distance should also be equal. So this will be moving in this direction. So we can mark this as some other point, say B1 dash. So this can be marked as another point. And this A dash B1 dash will give you the true length as well as true inclination. So this is the condition, and this can be reversed also. So what we do is, we assume that the line is parallel to VP, and we draw. And by drawing it, we obtain that this is the true inclination. So we obtain the length of the top view. This is the length of the top view, and in that case, this will be this point, this line. This line can be considered as the locus of B dash. Why it is the locus of B dash? So depending on its inclination, depending on the inclination of the line with respect to VP, the point B dash will be moving along this line, It will be moving along this line. So that is why it is the locus of B dash. So that way it can be obtained.